Okay, here is section 2.2. It's on graphs of equations in two variables. We'll talk about intercepts and we'll finish up talking about symmetry. Start off with graphs of equations. Here's the definition of a graph. It's not a formal definition, but it's all points x and y which satisfy a given equation. Satisfy means if you plug the particular x and a particular y in, both sides will be equal. That's what it means. It satisfies a given equation. This was its first example. It says, do these points lie on the graph of the equation? Here's my equation. And then I've got three different ordered pairs here. So I'll need either a yes or no for each one. So to determine if these ordered pairs lie on the graph, an ordered pair, x comes first and then a y. So we're just going to test each one. Alright, let's test 0, 0. If I plug 0 in for x and y, I'll have 0 equals 0 cubed minus 2 times the square root of 0. Alright, that 0 equals 0. Check. The answer is yes. Alright, so the point 0, 0, yes, it lies on the graph of that equation. Let's check 1, 1. When x is 1, is y equal to 1? 1 equals 1 cubed minus 2 times the square root of 1. Let's check this one out. 1 cubed is 1. The square root of 1 is 1. 1 minus 2. Look, you'll get 1 is equal to negative 1. That is a no. Alright, so if you plug those in, this was a 1, 1. Plug 1 in for the x's and 1 for the y. Those two are not equal. 1, 1 does not satisfy the equation, so your answer here is no. It's not a solution. Let's check negative 1 and 1. Whoa, plus, minus. Alright, x is positive 1, y is a negative 1. Right, my y is equal to that 1 cubed minus 2 times the square root of 1. Alright, so negative 1 equals 1 cubed is 1 minus 2. Negative 1 equals negative 1. That checks. This is a yes. Alright, so 0, 0 lies on the graph of this equation. The 1, 1 does not, but 1 comma negative 1 does. So yes, no, yes. Alright, let's scroll down and see what's down here. Alright, we're going to talk about intercepts down here. Alright, intercepts. There's a definition of what an intercept is. There's two different kinds because I've got two different axes. Those are points where the graph crosses or touches either the x-axis or the y-axis. So we will have x-intercepts and we will have y-intercepts. The two little bullets underneath are how you find them algebraically. To find an x-intercept, could be more than one, you plug 0 in for y into your equation and then you solve for x. So whatever x's those are, it's where it crosses your x-axis. For your y-intercept, there should only be one. If the graph is a function, you could have a graph that's not a function, like a circle, and that's okay. You might have two y-intercepts then also. Alright, you let x equal 0 and then you solve for y. When we do this, we always want to write them as ordered pairs because they are actually ordered pairs. They're points. And if you recall, graphing lines by plotting points, that was just one technique that you learned probably a while ago in an earlier algebra class, how to graph lines by plotting points. You can use that same concept or method to graph nonlinear equations also. Let's scroll down. Only about 4.5 minutes. Alright, let's look at this example. Man, if I can get up there. Alright, let's find the intercepts and graph each equation by plotting points. Right, this first one, will be a line, but this one down here will have a parabola, and that's okay. Alright, let's look at part A. Let's find those intercepts. To find an x-intercept, you let y equal 0. Alright, so that would mean 5x plus 2 times 0 is equal to 10. So that means 5x equals 10 and x equals 2. Yeah, so that was actually 2 comma 0. When y is 0, your x comes out to be 2. Alright, let's do the y-intercept. To find a y-intercept, you let x equal 0. So here I'll have 5 times 0 plus 2y equals 10. 2y equals 10, y equals 5. So in that case, x is 0, y is 5. Alright, let's just plot these two. Since it's a line, that's all we need to graph this. Your x-intercept is 2, 0. My y-intercept is 0, 5. Again, it doesn't have to be perfect, but it won't be. Draw that as best you can. Here, I didn't have to plot any other points. I just plotted those two. The two intercepts were enough to graph this. So that was for a line. Now I'm running up on 7 minutes, but let's just take a couple more minutes and finish this last one. We want to find these intercepts. I think that one was y equals x squared minus 2 for part B. Alright, let's do those intercepts. For an x-intercept, let's let y equal 0. Alright, so I'll have 0 equals x squared minus 2. Solving this for x, let's use the square root method. Don't forget plus minus square root of 2, which is approximately 1.4. Again, approximately. Those are my x-intercepts. We'll graph those in a minute. Again, I have two of them. And as ordered pairs, it's 1.4, comma 0 and negative 1.4, comma 0. Let's do that y-intercept. This is a little sloppy. Gosh, I hope your notes look a little better. For a y-intercept, let's let x equals 0. So I'll have y equals 0 squared minus 2, y equals negative 2. So that's 0, negative 2. 1, 2, 3, 4. Alright, we're actually going to plot another point besides these, a couple other ones. Let's put these intercepts on here. Y-intercept is 0, negative 2, this one. My x's are at plus and minus 1.4, a little less than 1.5. And on the negative side also. Alright, yeah, I am going to have a parabola. It's going to look like that, but let's go ahead and do, let's plug 2 in and see what it looks like. Again, this is a little plotting points one where you have your x and you figure out what those y's are. Let's do positive 2 and we'll do negative 2. When x equals a positive 2, I'll have y equals 2 squared minus 2, which is 4 minus 2, which is 2. I'll have the exact same thing if I let x equal negative 2. If you square a negative 2, you'll get 4 minus 2 is 2 also. So let's plot those last ones and draw this parabola. When x is a positive 2, y is positive 2. When x is negative 2, y is still positive. And remember, when you draw a parabola, it should be a nice, smooth curve, just like that. Alright, this was first couple pages of this section 2.2, and I'll do some more in another video.